Welcome back. We've talked about how industrial automation works and what the industry is really like. Now it's time for what I think is everyone's favorite part of the podcast, the stories. People remember stories far longer than they remember definitions. You've spent years designing automation solutions, working in factories, and building your own startup. I'm sure not every project went according to plan. Let's start with a project that almost failed.
More than one. One project still stands out because it taught me one of the most valuable lessons of my career. A manufacturing company approached us because their packaging line kept stopping randomly. Sometimes it would run smoothly for 6 hours. Other times it would stop every 20 minutes. The strange part was that no error message appeared. Every time we visited the factory, the system worked perfectly. It was like taking your car to the mechanic only for the strange noise to disappear the moment you arrived.
Those are always the hardest problems to solve. Where did you begin?
Our first instinct was to check the PLC program. Everything looked correct. Next, we checked the sensors, no issues. Then we inspected the motors, communication cables, network switches, and electrical panels. Still nothing. For nearly 2 days, we couldn't reproduce the problem. Instead of guessing, we decided to collect more data. We installed additional monitoring tools to record sensor signals, communication status, and controller activity over time. A few hours later, we finally spotted the pattern.
What was causing it?
A vibration sensor mounted near a heavy machine had developed an intermittent internal fault. Most of the time it worked perfectly, but whenever vibration reached a certain level, the sensor briefly produced incorrect readings. The PLC interpreted those readings as a dangerous condition and safely stopped the entire production line. The automation system had actually done exactly what it was designed to do. The real issue wasn't the PLC, it was faulty input data.
That's fascinating. Many people assume software is always responsible when machines stop.
Exactly. One lesson every automation engineer learns is this: good decisions depend on good data. If sensors provide incorrect information, even the best software will make incorrect decisions. That's why debugging industrial systems means looking at the complete picture, not just one piece of it.
Was that the biggest lesson you've learned?
One of them. Another came from a customer who wanted a machine to operate faster. Their management team believed increasing conveyor speed would immediately improve production. Technically, we could increase the speed, but our engineers noticed something else. The inspection station farther down the line couldn't process products that quickly. If we increased speed, inspection accuracy would decrease, defective products would pass through, and quality complaints would increase. Instead of saying yes immediately, we simulated the entire production process. The results confirmed our concern. The bottleneck wasn't the conveyor, it was the inspection system. By improving the inspection process instead, production increased without sacrificing quality.
That's a great example of solving the right problem instead of the obvious one.
Exactly. Customers often describe symptoms. Engineers have to identify the actual cause. If someone has a headache, giving painkillers may help temporarily, but if dehydration caused the headache, drinking water solves the real problem. Industrial automation follows the same principle. Don't treat symptoms, understand systems.
Let's talk about bugs. What's the strangest bug you've encountered?
This one still makes me smile. A robotic arm occasionally refused to pick up products. Not always, just occasionally. The mechanical engineers inspected the robot, everything was perfect. The electrical engineers checked the wiring, no issues. The software team reviewed the control logic, nothing looked wrong. Eventually, one engineer noticed something unusual. Bright afternoon sunlight was entering through a window and shining directly onto the optical sensor. The sensor couldn't reliably distinguish products from the reflected light. Every afternoon, for about 20 minutes, the robot became confused. The solution? A simple protective cover over the sensor. It cost less than a cup of coffee. Sometimes the smallest changes solve the biggest problems.
That's incredible. I imagine experiences like that teach engineers to avoid making assumptions.
Absolutely. One of the biggest mistakes beginners make is assuming they already know the cause of a problem. Experienced engineers observe first, measure second, analyze third, only then do they propose solutions. The fastest answer isn't always the correct answer.
Have you ever made a mistake that became an expensive lesson?
Yes, early in my career, we completed an automation upgrade for a production line. The software passed every internal test. The electrical systems worked perfectly. The customer approved the installation, everything looked ready. Then, during full speed production, unexpected delays started appearing. Not because of faulty programming, not because of hardware. We had overlooked one small operational detail. Factory operators occasionally paused the line to inspect products manually. Our software hadn't considered those interruptions. Over several hours, tiny timing mismatches accumulated and eventually disrupted production. Technically, the software worked. Operationally, it didn't match real world workflows. That project taught me something I'll never forget. Automation isn't just about machines, it's about people using machines.
That's an important distinction. Many people think automation removes humans from the process.
Not at all. Operators, maintenance teams, supervisors, production planners, and engineers all interact with automated systems. If your design ignores how people actually work, you'll eventually run into problems. Good automation supports people. Great automation feels almost invisible because it fits naturally into daily operations.
You've now worked both as an engineer and as the founder of an automation startup. Has that changed the way you approach projects?
Completely. When I was only an engineer, I focused mainly on technical excellence. As a founder, I learned that customers don't buy technology, they buy outcomes. They want fewer machine stoppages, higher product quality, lower operating costs, safer workplaces, better production visibility. Technology is simply the tool that helps achieve those goals. That mindset changed how our entire team approached engineering. Instead of asking, can we build this? We started asking, will this genuinely improve the customer's business?
Let's imagine someone listening to this podcast joins an industrial automation company next year. What's one habit they should develop from day one?
Keep a troubleshooting notebook. Every unusual problem you solve becomes part of your engineering experience. Write down what happened, what symptoms appeared, what did you initially suspect, what was the actual cause, how was it fixed, how can it be prevented next time. After a few years, that notebook becomes one of your most valuable resources. Experience is simply a collection of solved problems.
I love that. Before we close this segment, can you share one sentence that summarizes engineering in industrial automation?
Certainly. Machines rarely fail without leaving clues. Great engineers learn how to notice them. That's what makes this profession so rewarding. Every challenge teaches you something new. Every project improves your thinking, and every solved problem makes you a better engineer than you were yesterday.
What a fantastic way to end this chapter. Today's stories reminded us that successful automation isn't just about writing code or installing hardware. It's about observation, teamwork, patience, systematic thinking, and understanding how every part of a system works together. In our next segment, we'll step away from project stories and look at everyday life in this profession. What does an industrial automation founder actually do from morning to evening? How do teams collaborate? What tools do they use? And where is this industry heading over the next decade? Stay with us for part 5.